Hi, Jake. Let's take a look at this review sheet. I'm going to just answer the question here. So is this a function? Indeed, this is a function. Because for each x value that I plug in, there's only one g of x or y value that comes out. So it's a function. The domain, range, and discontinuities. The domain would be from -5 to +5. That's inclusive. So I'm using these brackets. So that's the domain. I don't know how your teacher has you write that out. So we can talk about that if that wasn't clear how that happened. But if I use any numbers outside of that domain, I'm going to get negative numbers underneath the radical. My range is dependent on my domain. I could obviously graph this, which might be pretty helpful. I can plug and chug numbers to see what I get. But if you think about it, what's the highest value I can get with 25 minus x squared? Well, obviously putting 0 in. So the highest value I get here is 5 for the range, and the lowest value is going to be 0 when I put 5 or -5 in. Finally, the discontinuities, there are no discontinuities. This is a continuous function, so the discontinuities are none. And discontinuities, if you remember, comes from having a 0 in a denominator, and this is not fractional, so you should be okay in terms of discontinuities. And zeros, well, that should be pretty clear. When I plugged in -5 and 5, I get 0. So my zeros are at x equals -5 and x equals 5. I think you may recognize the problems in part 2 as seriously problems that we talked about earlier today. So if you look at the next part that we need to look at is 4. We can talk about what type of symmetries each of these guys have. So I've included a little bit of the information that we need to know in terms of the test. Remember, if AB implies A negative B, then we've got x-axis, and you can see the other ones that we discussed today. So look at here, I just wrote down the answer for number 2. It had y equal x symmetry and the origin symmetry. And number 3, I believe it only has x-axis symmetry. So looking at this guy, remember what we have to do. We plug in, we say what happens with a squared plus b squared would equal 4. If I put in a negative b, what happens? I still get a squared plus b squared. So I see that a squared plus b squared equals 4. So it does have x-axis symmetry. Similarly, if I put in negative a and b, I would see that we have y-axis symmetry. So I'm going to put down x-axis, y-axis, and you probably already figured out that all of these work out because I'm really just squaring and adding the two coordinates together. So it literally has everything. All right, let's move on. In part 3, we're going to sketch each of the following, and we're going to explain what the effect was on the original function. So this new function that we're going to do in number 5, we're looking at absolute value. Everything negative must come up, right? Because what was negative y is now positive. So I'm going to try to be neat about this. That goes up. We're going to leave the top part there because absolute value of a positive is a positive. This comes up like that. And then this guy is going to come up like that. So everything that's below is going to come up. So that's for the first one. Let's use another color to represent this next guy. If I have negative f of x, that's a reflection. So this is going to look confusing, but I'm going to try it anyway. What was down goes up and what's up goes down. So we have some similarity with the last one, but things that are positive become negative. So that red graph represents negative f of x. Finally, we have f of x minus 2. Do you know where this is going? Is it going to the left or to the right? I hope you said no, it's going down because this negative 2 is outside of the parentheses, and when it's outside of the parentheses, it's going to shift vertically. When it's inside of the parentheses, it'll shift horizontally. So let's use orange here for this function. If we're shifting it up, we're looking at the original function. If we're shifting it down by 2, instead of starting here, we'll start down here. Let's say this is 2. Instead of being here, we'll be further down here, go up to about there, and I think you get the idea of what we're doing. So I'm going to try to put some dots around here to use this as a guide for graphing my answer. Okay, that's the best that I can do. I think that you can probably do a better job. You were working really much more efficiently when we were doing this together, so you get it. All right, let's look at the rest. Okay, so number 8, we're going to explain when a function has an inverse. And I'm not going to write this out, but I'll tell you, a function has an inverse when you exchange the x and y values, find the inverse function, and it is a function, and it has to be a function. That's when it has an inverse. So if you start off with a function, you exchange the x and y values, and then you get a function, you have a function with an inverse. I'll do a quick example. If y equals x squared, if I'm looking for the inverse, let me do that in this strange orange color. I would say x is equal to y squared, and then I'd solve for y. So I'd have to say, well, y is equal to the square root of x, but I'd have to put plus or minus. This plus or minus makes this not a function because for one x value, I'll get 2 different y values. So again, if you have a function and you find the inverse and the inverse is a function, boom, your function has an inverse. So with these guys, we're going to do g of h of 5. When you're given a number, what I would do is actually just evaluate that expression or that equation at that number and then continue on. So h of 5 is equal to 20. So because I have that 20 now, it's easy for me to go back into g of x. G of 20 is, should make that a 20. G of 20 is equal to 2 times 20 minus 7, and then that's obviously 40 minus 7, which leaves me with 33. So the answer to this guy should be 33. Over here, h circle g of 3 is really just another way of writing g of 3, h of g of 3. So I think I would process this in the same way. Figure out what g of 3 is first, and then get 2 times 3 minus 7, which is going to be 6 minus 7, which is negative 1. And now I'm going to take h of negative 1 and process that. So when I throw a negative 1 in there, I get 1 squared, basically 1 squared minus 5, because negative times negative is a positive, and then I end up with negative 4. So the answer to this guy is negative 4. Finally, we're looking at composite functions here. So here's where I actually have to just take h of x and plug it right into the equation. So I have 2 times x squared minus 5, close parentheses, minus 7. I would even eyeball this a second time when you do this so you don't miss any signs or stuff like that. All right, after you've done that, you're going to do like you usually do, simplify this expression by using distributive property. We have 2x squared minus 10 minus 7, join some like terms together. Now we've got 2x squared minus 17. The question here is, are g of x and h of x inverses? And the answer is no. When I compose these two functions, well, let's go back. The definition of an inverse is that if I take g of x, if I take f of g of x and g of f of x, if the answers are equal and if both of those answers are x when I compose them, then I definitely have inverse functions. In this case, notice when I compose g and h of x, I was only able to get another expression, 2x squared minus 17, which is obviously not x. Therefore, they are not inverses. Okay, so as we look at number 10, I am comfortable with this problem, but I wish that it didn't have so many variables because I think the multiple variables might make things a little bit challenging. However, we can fight through it. A box with a square base has no top and a volume of 6m cubed. We know that the volume of a box is going to be equal to length times width times height. And we know that in this case it's 6m cubed. I'm going to draw a quick picture of what this box may look like, and so we can think about it in process. Not the best drawing, but I think you get the idea. We're told that the total surface area A of the box has to be a function of the width of the base. So the base, being a square, will have the same width and length. So here we've got W times H is equal to this given value of 6m cubed. Now let's consider surface area. Surface area is defined as the area of the base. In this case, the area of the base is going to be W times W, so that's W squared, plus the area of the sides. And to get that, we do the perimeter of the base times the height. The perimeter of the base times the height. So that's going to be 4W times H. Now, in this case, we were asked to have everything in terms of W. This is cool, this is cool, this H is not. Now here's where the thing gets a little weird. If we're going to have everything in terms of W, this M seems to be a sticking point. But your teacher has it there, we need to have M in the equation. So we've got W squared times H is equal to 6M cubed. We're going to solve for H by dividing both sides by W squared, and we get that H is equal to 6M cubed over W squared. I'm going to replace that in this equation. So W squared plus 4W times 6M cubed over W squared. With a little bit of simplification, we get that W squared, the 4 times 6 becomes 24. We can cancel out 1W from the numerator and denominator, and I get 24M cubed over W. And that is my best estimation of what your teacher wants. Throwing that M in there makes things weird, but that's the best we can do. Let's look at number 11. We're going to express the area of A of a triangle, of a 45-45 right triangle, as a function of the hypotenuse. So what we need to do is kind of get back into the zone of remembering the relationship between the sides of a 45-45 right triangle. So they want us to use H as the hypotenuse. And that's going to ask us, well, what would be the legs? We know that both of these are going to be equal in length because this is an isosceles triangle. We need to figure out what they would be in terms of H. A couple ways to do this. We can call this X, and then solve. We could also recall the relationship between the lengths of the sides of a triangle like this. And if you remember, I'll put a little thought bubble here. We remember we had S, and then this was S root 2. So what that tells me is that if the hypotenuse is this, the sides would be this with root 2 divided away. So technically, the lengths of the sides would be H over the square root of 2. All right? A little bit weird, but you can use a Pythagorean theorem to actually figure that out. So now what we're going to do is find the area, because we're looking for the area of this triangle. Area is equal to 1/2 base times height. Please don't let the H confuse you. This is height, not hypotenuse. So this could be the base, and this could be the height. I don't really like using that H. So since they're both the same, I'm going to put BB. I got 1/2 B squared is equal to the area, but we don't want B, we want it in terms of H. So we know that B is equal to H over the square root of 2. I'm going to plug that in there. H over root 2, put parentheses around it, square it. That's the area. Do a little bit of simplification. When I square root 2, I get 2. In the denominator, when I square H, I get H squared. So my answer finally is H squared over 4, because I have this 2, this becomes 2 when I square it, and this is 2 times 2 is 4. So this is my answer. I hope this was helpful. Give me a call. Let me know if I can assist you in any other way. Good luck on your test. Take care.